So what we have here, we have a fx equal a square root of x at a equal 4. So what do we want to do? We want to write a linear approximation to a square root of x. One of the most powerful application of the derivative is you'll be able to write any function, trigonometric, radical, any function in terms of the linear approximation at the certain value. For example, here we want to write a square root of x as a linear approximation. That's a general formula. So what do we want? We want, uh, definitely we want f prime x. So f prime x is equal 1 over 2 a square root of x. F prime a, in this case, our a is 4. So you get 1 over 2 a square root of 4, which is 1 over 4. And then we want f of 4, which is 2. So we are ready to write that linear approximation. So Lx for a square root of x is f of a plus f prime a times x minus 4. So this is our linear approximation at a equal 4. So because here Lx is equal 1 over 4x plus 1. So what we're claiming here, if this is the square root of x, y equal a square root of x, at a equal 4, so when x is 4, and of course the y is 2, we have a linear approximation at, let me change there, at something like that. We have a linear approximation at x equal 4. That's how powerful it is. Later on in calculus, advanced calculus or calculus 2, you'll be able to write any polynomial function and any degree of the polynomial. Please allow me to teach you math. I'm the guy who goes a step by step. In no time, I make you a perfect mathematician. It's about experience, and I go step by step. And I'm always online. Doesn't matter where you live. I can always help. Please follow me and subscribe. It means a lot to me. Thank you.